and conduct them down the external auditory canal or meatus, where then the sound waves are going to beat a little rhythm on the eardrum, tympanic membrane. From the tympanic membrane, it goes to the auditory ossicles. The first one's called the malleus or hammer. And then we go to the incus or the anvil, to the stapes or stirrup. Okay? Now, the first two areas here, external and middle ear, and this is where the auditory ossicles are only for hearing. And there's air here, some hair, some earwax, some bugs. Okay? And then this auditory canal or the eustachian tube or pharyngotympanic tube, this is normally collapsed, but it opens up when you yawn or chew or something like that to equalize pressure on both sides of the eardrum. Otherwise, it can be painful and also make it hard to hear. Now, the inner ear is carved out of bone, so that's called the bony labyrinth. It's in the petrous portion of the temporal bone. And then lining that is a membrane, a membranous labyrinth. Now, there's three parts to it. There's this cochlea, which is missing part of it right there, okay? That's for hearing. The vestibular complex includes the vestibule and the semicircular canals. The vestibule has two membranous sacs, the utricle and saccule, and therefore static equilibrium, like which way is your head turned? Is it upright or whatever? And linear acceleration. So it has these things called maculae, that's the receptor. It has little hair cells sticking up into a gelatinous material. And in the gelatinous material are little, what we call otoliths, which is the calcium carbonate. When you tilt your head, gravity pulls on it and moves the hair cells. That tells you which way your head is tilted, okay? Then in the semicircular canals, we have what we call the ampullae, kind of large areas, the base of each one. Notice they're at 90-degree angles to each other, so they tell you which way your head is moving. So that's dynamic equilibrium. And in there, we have something called the crista ampullaris, which has these little hair cells sticking up inside a gelatinous thing called the cupula. And when you move, fluids push on that, and it's going to push differently depending on which way your head is turning. So you can tell which way your head is turning by which ones are stimulated. Now, these are all connected. All the channels are connected together. Now, when we're going for hearing, when we go from the larger area down to the smaller area, that's not just going to conduct the sound, but also amplify the sound waves. Okay. Now, in here again, you need to look at the pictures because you'll see that it's a repeating structure. Three scala. We have the scala vestibuli, and that's what's attached when we push on the oval window. That causes pressure waves in the scala vestibuli. Those pressure waves then eventually go to the basilar membrane, which is underneath the organ of Corti. As it moves up and down, the organ of Corti moves up and down, and the hair cells that are embedded in the in the tectorial membrane get bent. And that tells you what frequency of sound you're hearing. Near the oval window is where you hear high frequency sounds. Towards the tip apex is where you hear low frequency sounds. Then some other of the rest of the sound waves, pressure waves, are eventually going to go through the stela tympani and push out on the round window, which kind of dampens the sound. Because you push it in one place, you've got to push out some other place. Okay? So make sure you look at the cochlea and the organ of Corti there, because that's what you hear with. And I think that's about it.